Let us have this one last more example for generalized pigeonhole principle so we can move into other concepts as well in this playlist. This tells us that a web server distributes requests among 6 servers. How many requests ensure that one server will handle at least 9 requests? So this is an example of a pigeonhole principle, because if you talk about pigeonhole, you have your placements. You will be asked about the number of pigeons needed so that these pigeonholes will actually will be used more than one time. So 2 times, 3 times, in this case at least 9. So in this case here, let's try to identify first what would be our pigeonholes. The pigeonholes, as mentioned, would be the placements. Okay, the placements for something to pass through, and that's actually your number of servers, because that is where the request will, or that's the item that will receive the distributed request by the web server. Okay, so that is actually your n, and you're given with 6 now. Now for your pigeons, these are the items that will pass through your servers. In this case, the pigeons will pass through your pigeonholes. So the pigeons here are actually your requests, because these are the items again which will be assigned or distributed to the servers, or the 6 servers specifically. That's the item we're trying to know, to solve here. How many requests are needed to ensure this certain criteria here? So this is actually kn plus 1, not n plus 1. Okay, n plus 1 is not for generalized pigeonhole principle. That happens when here you're actually asked about at least 1. So if you're asked about at least 1, or I mean at least 2 rather, at least 2, you just actually need 7 requests to be assigned to our 6 servers, because the first 6 of those 7 requests, assuming that the web server will assign 1 for each, of course they will be evenly distributed. The 7th one, the additional request, will make sure that one of those servers will have at least 2 requests. But that is for non-generalized. Now we are generalizing it and even have the target of at least 9. So we have this formula according to the generalized pigeonhole principle. Now where do we get our k, because our n is already given? According to the generalized pigeonhole principle, it states that if n pigeonholes are occupied by kn plus 1 pigeons, then at least one of those pigeonhole will occupy k plus 1 or more pigeon. Again, let me repeat, k plus 1. In this statement, this is the k plus 1. So k plus 1 is 9. K is not 9, but k plus 1 equals 9, which will give us 9 minus 1. K would be 8. So please take note of that, because it might be incorrect. Of course, we will be having a sort of checking later on to verify our claim here. So with that k being 8, you have here 8 times n, 6 servers, plus 1. That's actually 48 plus 1. You need 49 requests to ensure that at least one of those 6 servers will handle at least 9. How do we verify this if we are not yet convinced? Let's say, again, the web server is being fair and assigning 1 for each server without doubling the other, and then without leaving one server empty. So say for example, the first 6 assignments is assigned to each of the 6 servers. So we have not yet reached at least 9. Let's say 7 to our 12th request, by assigning that to 6 servers fairly, so each of those servers will have 2. Okay? But we have yet reached 9. So we'll have here 13 to 18, that guarantees at least 3. From 19 to 24, that's still so far, that's just 4 per server. You will have 25 to 30, gives us 5 per server. Let's take of this analytically and think of the implication. 31 to 36, that's 6 per server. Again, our target is at least 9. You will have here 37 to 42, that's 7 per server. You will have here 43 to 48, that's actually 8 per server. Okay, assuming again that it's fairly distributed, not that in 7, 8, 9 here is assigned to just one server and claiming that we already arrive at our conclusion. Now, for this 48 requests, still, each of the server is distributed or given with 8 requests. That would mean if we add one more, even if this is assigned to server 1, 2, 3, 4, 5, 6, it will guarantee that one of those 6 servers will have at least 9, even exactly 9, but at least just talk about at least 9 requests. So 48 plus 1 is actually 49. This actually supports our solution for with the use of generalized pigeonhole principle. So again, this will be the last example for generalized pigeonhole principle, and we will go proceed to another concepts to this playlist for deeper understanding on concepts on combinatorics. Thank you very much for watching.